Hello, Algebra 1 students. Today we're going to be doing the Unit 6 unit activity. Sorry, not the activity, the unit review, which is at the end of the unit. So if you can, go ahead and go to the unit review, which is at the end of the packet, starts on page 61. Now, if you haven't done the rest of the packet up to this point, then you shouldn't be watching this video. So you need to complete the entire packet up to the review and then watch this video. Now, you should also work on the review on your own, see which ones you could do by yourself before watching this. Now, I want to emphasize everything I write down, you should be writing down. Also, there will be some things where I just tell you you should need to write it down, and you need to write those down as well. So let me go ahead and close this quick. Okay, let me open up. All right, here we go. All right. So graph and label each cell phone plan as accurately as possible. You need a ruler or a straight edge to draw each straight line for each cell phone function. So I would suggest having a ruler or some other sort of straight edge to graph these. So let's look at cell phone plan A. So they give you the X values and you need to find the Y values. So what we're going to do is plug each of these X values into this equation. So for example, plugging in the 0 would look like this. Y equals 0.70 X. Now I'm replacing X with 0. So that's going to be times 0 plus 30. So this will be Y equals 0.70 times 0. Well, that's just 0, right? Anything times 0 is 0 plus 30, and that gives you 30. Okay, let's try the next point. So I'm going to replace, this time I'm going to replace X with 50. So it'll be Y equals 0.70 times 50 plus 30. So that'll be Y equals, so you would do 0.7 times 50, that's 35, plus 30, which is 75. Or sorry, 65. I can't add. Okay. Let's do the same with 100. Again, replacing X with 100. So that would be Y equals, so this would be 0.70 times 100. Again, replacing the X with 100 plus 30. So this would be Y equals 0.7 times 100 is 70. So this would be 70 plus 30, which is 100. Okay, so 100 comma 100 for this point. Okay. See if you do these last 2 points on your own. Again, replacing X with these values here. For this one, it's more the same. So for cell phone plan B, you're going to replace the X coordinates with, or the X in the equation with each X coordinate. Okay, so replacing X with 0, this would be 0.25 times 0. Well, that'll just become 0 plus 100. So that'll give you 100. Okay, let's go ahead and replace X with 50 in this one. So this would be Y equals 0.25 times 50 plus 100. So that would be Y equals 0.25 times 50. That gives you 12.5 plus 100. That'll give you 112.5. Okay. So let's kind of explain what we're finding here. So this X is the number of minutes you use, and the Y is the cost of the plan at the end of the month if you use this many minutes. So for example, in cell phone plan B, if you used 50 minutes, then so 50 minutes in the month, then the cost at the end of the month would be $112.5. So $112.50. Okay. And then you'd go ahead and find the rest of these as well. You could see that if you talked for 0 minutes, would you rather be with cell phone plan B or cell phone plan A? Well, if you talk for 0 minutes, cell phone plan A would only cost $30, whereas cell phone plan B would cost $100. You see the difference there if you talked for 0 minutes. If you talk for 50 minutes, you could see the difference in the prices there, right? Okay, but go ahead and finish the rest of these charts, just like how we did with these examples. So for cell phone plan C, it just says Y equals 150. That means it's 150 all the way down. So this one should be 150 all the way down. So because it just says Y equals 150, that means that basically you pay $150 and it doesn't matter how many units or how many minutes you use. It just costs $150 regardless. So let's go ahead and graph each of these cell phone plans on the graph. So first, let's look at cell phone plan A. We can see it has 0, 30 as one of its points. So 0, these look like they're going up by 20s, right? 20, 40, 60, 80. Okay, so 30, 0, 30 would be like right here between 20 and 40. Also, probably the easier point to use would be 100, 100. So I'm going to use that. 100 right here, 100 right here. Now, you should be able to graph all of the points on this chart. And the points, when you graph them all, they should line up and form a straight line. Okay. Now, my line's not perfect because I'm not using a straight edge, but hopefully yours turns out even better than that. Actually, that one turned out pretty good, I would say. Okay. So this, I'm going to put an A here because this is cell phone plan A's graph. What about for cell phone plan B? So 0, 100 is 1 point. 0, 100. Okay. I can graph this point 50, 112.5, but I think that might be a little bit hard to do here. So maybe I'll try to find this other point here. If I plug in 100, this will give me 125. Okay, that might be a little bit easier to graph for me. So 100, 125. So 100 is on this line, and I want to go up to 125, which would be like here-ish. So I would connect like that, like so. So your graph should look something like this. Again, you should be able to graph all the points here and form a perfectly straight line with all these points. Okay, and for cell phone plan C, it's just 0, 150. So 0, 150 would be like here. And then all the y coordinates are 150, so it's just 150 straight across like this. Okay. Again, hopefully your lines turn out nicer than mine. I'll put a C here. Okay. All right. So explain in your own words which cell phone plan from question 1 you would recommend to a mother who only uses her cell phone for emergencies. So if someone's only using their cell phone for emergencies, that means they're not going to talk very many minutes. So let's say that they only, so which plan should they go with? Well, if their minutes, which is the x-axis, is very few, let's say they do 40 or fewer minutes per month, then they should go with the cheapest one. So that's the first one that it crosses. So that would be, in this example, in that instance, rarely using your cell phone, you should go with cell phone plan A if you rarely use it, right? You can see later on, if you have a lot of minutes, cell phone plan A is the worst one to go with. But you see, if you use very few minutes, then cell phone plan A is the best choice. So I want you to explain that briefly here, that someone who uses their cell phone rarely or only for emergencies, they should choose cell phone plan A because it would be the cheapest one for them. Okay, so go ahead and pause the video and explain that there. Question 2, part B. Explain in your own words how the slope of cell phone plan A is different than the slope of cell phone plan C. Be as specific as possible. So for the, hopefully you remember in the equation of a line, like if you have an equation in this form, y equals mx plus b, the m is the slope. The m is the slope. So if we're looking at cell phone plan A, then what's the slope of cell phone plan A? Well, the slope is 0.7. You see that there. The slope is 0.7 for cell phone plan A. Well, what's the slope for cell phone plan C? Well, it just has a y equals 150. It doesn't have something times the x, right? But notice it's just a straight horizontal line. A horizontal line has a slope of 0. So you would say that cell phone plan A has a slope of 0.7, and that's why it's going upwards, right? A positive slope, it's going upwards. And cell phone plan C has a slope of 0, which is why it's a perfectly horizontal line. Right? So I want you to explain that there. Okay. Cell phone plan A has a slope of 0.7, which gives it that upward trajectory, whereas cell phone plan C has a slope of 0, which is why it's a horizontal line. Okay, question 3. Tickets for a school carnival cost $10 for adults and $5 for children. Last Saturday's carnival sold 170 tickets worth a total of $1,200. How many adults and how many children attended the carnival? You must set up a system of equations to solve and then show your work and how you arrived at your solution. So we're going to need two variables here. We have x and y. So we're going to have x, and we might want to define our variables. It's always a good idea. If the question doesn't define your variables, then you probably should. So we're going to let x equal the number of adult tickets. Okay. And let y equal, what do you suppose y would be? It's the number of children's tickets. So the number of children's tickets. Now, some problems, they will define the variables for you. Like they'll say in the problem, like let x equal, let y equal. But if it doesn't have that sort of thing, it's always a good idea to define your variables ahead of time. And it'll help you make sense of the equations as well. So if we add the number of adult tickets plus the number of children's tickets, that'll equal how many tickets? Well, in this case, 170. So the number of adult tickets plus the number of children's tickets is 170 tickets in this case. Now, we also want to consider the values of those tickets. So for the adult tickets, they were $10 each. So it's $10 times the number of adult tickets. That's how much money they brought in. They brought in $10 times the number of adult tickets. For the children's tickets, they were $5 each. So $5 times the number of children's tickets. and that tells you how much they brought in revenue. So in this case, $1,200. Now, we basically want to solve for x and y in this case. Now, for me, the simplest way would be to use the elimination method. And we're just going to say we're going to eliminate the y values in this case. In order to eliminate the y values, I'm going to multiply this equation by -5. So -5, the reason it's -5 here is because I want this to be -5y, and that'll cancel with the +5y of this equation. So basically, you want to find something where one of the variables will cancel. Now, you could have canceled the x's by multiplying by -10 and cancel the x's. That's fine. That's an appropriate approach as well. But I'm just going to cancel the y's in this case. So the -5 gets multiplied by this first equation. So that's going to change it a little bit. So that's going to be -5x minus 5y equals -850. And then I'm going to write the second equation just right below it. And what we're going to do is we're going to add these equations together. And again, the y values are going to eliminate in this case when I add them together. So -5x plus 10x is 5x. This gives you 5x equals, and then -850 plus 1,200 is 350. Then, to get x by itself, we divide both sides by 5, which that'll give you that x equals 70. And x, if you remember, x is the number of adult tickets, so the number of adult tickets, that's 70. Now we can figure out y. We can figure out the y value by plugging this value into one of our original equations. Now, in this case, I'm going to plug it. You could use either equation, but I'm going to plug it into the top equation here. So my x plus y equals 170. Well, now I know my x is 70. So this will change to 70 plus y, again, replacing the x in this equation with what x equals, 70, equals 170. Solving for y, I would just need to subtract 70 from both sides of the equation, and you can see that y would equal 100 in this case. So there were 70 adult tickets and 100 children's tickets. And you could always check. There should be 170 tickets. Okay, that's correct. And if you multiplied the 70 adult tickets times 10 and the 100 children's tickets times 5, they should add up to 1,200. So you could check that on your own. Okay. Question 4. Follow along as I read aloud. A financial planner wants to invest $8,000, some in a high-risk stocks earning 15% annually, and the rest in a safer mutual fund earning 6% annually. How much should he invest in at each rate to get a return of $930 annually from the two investments? So this is kind of a tricky one. But we're going to define our variables. Let x equal the amount invested into the amount invested in the stock, in stocks. Okay, so he's investing some of the money in stocks and then some of the money in a mutual fund. Okay, so what do you suppose y is going to be? Let y equal the amount invested in the mutual funds. The amount. I know my writing is really slow and sloppy because I'm using a mouse. Invested in mutual fund. Okay. Now, the amount he invests in the stock plus the amount he invests in the mutual fund should equal his total investment. So what's the total investment? $8,000. So the amount invested in the stock plus the amount invested in the mutual fund will equal $8,000. The second equation has to do with their values. So this is kind of similar to what we did up here, right? The first equation had to do with quantity, right? How many tickets? Second equation had to do with the values, total value of these tickets, the value of these tickets, total value. This is similar. This is quantity. How much, how much, how much? And then now we're going to look at the values of them. So in the 15% for the stocks, so for the stocks, the investor gains 0.15. So this is 15% times however much is invested in the stocks. Now I change it to a decimal. From 15%, you move that decimal over twice to change it to a decimal. So this equals 0.15. It's going to be easier to write it as a decimal when we do the algebra. Now for the second equation, for the second variable, the y is the amount invested in the mutual fund. Now in this case, he earns 6% for the mutual fund investment. So to change that to a decimal, again, you move the percentage over twice. That's 0.06y equals, and then the amount he gets from his investments is 930. Like that. So these are your two equations. Now, similar to the one we did, the question 3, similar to question 3, we're going to multiply this first equation times something that will make it so our y's cancel. So in this case, I'm going to multiply by negative 0.06. That way, when I multiply this through, the y's will cancel. So this is going to get distributed in this first equation. So that's going to be negative 0.06x minus 0.06y equals, now we have to do negative 0.06 times 8,000. Which is negative 480. Okay, because negative times positive, that makes negative. The second equation, I'm just going to write it below here. So this is 0.15x plus 0.06y equals 930. Then we're going to add these two equations together with the y's eliminating, right? Because the negative, positive 0.06y, those cancel. So here, this would give us 0.09x, right? When we add those together, equals 930 minus 480 is 450. And then to figure out x, we're going to divide both sides by 0.09. This will give us x by itself. So 5,000. What does this mean? That means the amount invested in the stock is 5,000. So they invested $5,000 in the stock. So we're going to put 5,000 right here. Well, that means how much did he invest in the mutual fund? Well, remember he invested 8,000 in total. So if 5,000 went into the stocks, that means 3,000 must have went into the mutual fund. And again, you could have plugged it into this first equation and solve, or either equation, and solve for the y, and you should get 3,000. Okay, last question. A high school play costs an upfront $30,000 to produce, plus an additional cost of $1,000 for each performance. Every sold-out performance of the play brings in $2,500 of revenue for the school. How many sold-out performances are needed so that the school breaks even on the production of the play? Okay. So first we want to look at, we're going to write two equations here. And basically, these two equations are going to represent the cost and the revenue. So the cost of the play is $30,000 to produce, plus an additional $1,000 for each performance. So it's $1,000 times the number of performances plus another upfront cost of $30,000. Okay, so this is the cost equation. So this is the cost. This is the cost equation, right? The total cost is $1,000 times the number of performances plus another $30,000 upfront. Now let's also write a revenue equation. So the revenue is the money they bring in. So for each sold out performance, they bring in $2,500. So it's $2,500 times however many performances, X. Okay. Now it asks about breaking even, right? Break even. What that means is basically when the cost and the revenue are equal, then that's a break-even point. So I want to set these two equations equal to each other. Set the cost and the revenue. So this is the revenue equation. Set the cost and revenue equal to each other and solve for X. That'll tell you the number of performances. So notice there's X on both sides of the equation. So we want to bring all our X's together on the same side. What we're going to do is subtract 1,000X on both sides. That way we only have X's on the left side. So this will be 1,500X equals, on our right side, we have 30,000. To get X by itself, divide by 1,500. And that'll give you 20. So what does that mean? There would have to be 20 sold out performances in order to break even. Breaking even means you haven't gained money, but you also haven't lost money at that point. If you did fewer than 20 performances, you've actually lost money. If you do more than 20 performances, you'll start gaining money as a profit. Okay. I hope that made sense. And if you have any questions or you're stuck somewhere or something didn't make sense, you could always email me. My email is ttrigg@ofy.org. All right. Well, and with that, I'll see you guys next time, and good luck on the test.